Uh, Very good morning. It's a busy morning for all of us, and I just happened to be reaching here on time and to talk about transportation and traffic woes. Firstly, thanks to the organizers for inviting me and giving me this opportunity. In past, I've delivered many keynote lectures, guest lectures, expert lectures, but this is the first time I'm delivering a master class. It's a very interesting nomenclature. Almost sounds like Master GK class. Anyway, thanks again. I'll quickly get started with my presentation. Is my slide on? Okay, good. That's great. Looks like a 70 screen. Okay, so I'm going to talk about sustainable urban mobility and what smart solutions can help us to achieve sustainable urban mobility. So what we'll do is we'll first set the context of sustainable urban mobility so that we understand what these goals are and what sustainable urban mobility means. In fact, for a city like Bangalore or a similar city in India. And then we'll go on and talk about what are the smart solutions that we can have to achieve the sustainable urban mobility. So transportation discipline, as you would see the journey right from the automobile start of the automobile era, has been supply centric traditionally. When I say supply centric, the whole idea of transportation engineering or transportation planning had been to focus on supply of physical infrastructure, meaning we try to estimate how much more vehicles are going to come on the road and how much more road space is required. In fact, the earlier or initial methods of transportation planning had evolved in the United States, where right from the start of the automobile era, the only thing they were interested in knowing was that how many more cars will come in the future and how many more roads and road infrastructure and road capacity is required. So this is how the transportation discipline has started. So this has remained supply centric. As I said, we have always focused on adding physical infrastructure. But gradually we realized that there is constraint to this kind of transportation planning. There are limitations to what land resources are available. No matter how much our cities grow, the diameter of this planet is not going to grow. And we are still to find a habitable planet somewhere else where we can move from here and start living there. So we still have a constraint of the land space, no matter how much we can expand our cities. We also have constraint of resources. Every infrastructure need and development requires resources, material, natural resources, aggregates, everything is being extracted and mined from this planet itself. And we are now, to an extent, that we are seeing, limitation of these resources available uh, for everlasting or ever increasing infrastructure needs and requirements. We have also seen, the constraint of energy. We are still predominantly on fossil fuels, um, and that's not a renewable energy. And how much we can consume or keep consuming these fossil fuels, especially to run our transport system. We also now see, huge impact on the local environment in terms of the tailpipe emissions, the ambient air quality, how it is degrading. As you walk around or travel in our road environment, we can visibly feel and understand how much of air quality degradation we are seeing, including carbon emissions and greenhouse gases that are coming out of the transport. So all this, this whole traditional supply centric focus is now pushing us to the limits of these constraints. Okay, and on the top of that, the unique conditions that we have in emerging economies. are like, it's like tadka on the dal. Yeah. So all these heterogeneity of traffic system, we have in the same right of way different vehicle types mix with each other. Yeah, each of these vehicle class has its own static and dynamic characteristics, including the non-motorized modes, the those who are pedestrians, those who are cyclists, three-wheeled auto rickshaws, cars, heavy vehicles, and so on. It's a complete mix. Technically, when we try to study and model, we call it as heterogeneous disorder traffic. Okay, this is the typical characteristics or terminology that we use for our, and that has its own complexity. It's not easy to model. Non-lane based system, literally lane based system is absent in our road environment, especially in urban travel. Yeah, you really don't see any lane based system at all. Yeah, driving behavior issues, all of us see and understand these. How much of complexity this further adds to it, and poor integration between land use and transport. We are still missing, this whole idea of a integrated land use transport planning, a single master plan that takes care of land use and urban planning also, as well as transportation planning. Uh, you know, the master plans are still by town planners. The transportation plans are still done by transportation planners. They never marry each other. Along with this, the population growth. India is still a country where you still have absolute population growth. Coupled with that, the migration to bigger cities like Bangalore is further adding to the pressure of population. And of course, with the increase in population, your travel demand also increases in the city. Yeah, and so you keep having a higher and higher need of more and more, uh, you know, um, requirement to satisfy this travel demand. Coupled with that, the high density growth in the cities and exponential growth in the vehicle ownership, vehicle registration, and its mile. And this is further, accelerated after the COVID, because we have moved away from public transport system. So all this is leading to high transport externalities, which are quite visible to us. There's so much of unreliability of travel time in our, cities, um, and connected externalities, whether it is high tailpipe emissions, greenhouse gases, road accidents, and so on and so forth. And so there is a more and more growing focus on taking a systems approach towards sustainability, and I'll talk about that further. What this means, systems approach essentially means not looking at the issue of traffic congestion in isolation, yeah, or a bottom-up approach, or that engineering-based traditional approach, where you would just identify the congestion points and try to uh, do interventions that try to relieve those congestion points. That lacks a systems approach, because you may do something at one location, one junction, or one corridor. The impact of that would be felt somewhere else. In recent time, there was this double-decker bridge that was, inaugurated and was open for traffic. While it has relieved something at the Silkwood Junction, it has created multiple new locations of congestion point and hotspots. Yeah, so that systems approach and that thought process is missing. Systems approach also means that you look at transportation in with its linkage to these tailpipe emissions, impact on development goals, quality of life, health impact, and so on and so forth, equity issues, accessibility issues, and so on. And so we are now focusing more and more on sustainability. So world across now, there is a clear understanding that the supply-centric approach is no more sustainable. Yeah, this is not the way we can really go forward and just keep building infrastructure. So there is a growing focus on demand-centric approaches. That means to optimize. First, you optimize what existing infrastructure you have, and then think about anything more on the top of that. So disciplines like traffic management, how do you manage demand? How do you understand and model travel behavior? How people make travel choices and nudge those travel behavior or travel choices towards modes that are more sustainable, so that you not just have a long lasting solution for your traffic issues, but also make it sustainable. Okay, so this is now a growing focus in terms of how transportation discipline is looking at problem solving in transportation. And so there is a shift of focus on reducing volume rather than capacity. This V by C ratio, it's a magical uh, ratio which transportation engineers have been using for quite long, but without really understanding the potential. So what is the ratio is? It is the volume divided by capacity on a given road, expressed in same unit, say vehicles per hour or passenger car units per hour. What has been the approach always of our engineers, for example, sitting in BBMP, is to estimate this V by C ratio. If volume is closer to capacity, the ratio will reach closer to 1. That means that's a congestion point or a congestion hotspot. So what BBMP will do is, okay, let me widen the road, or let me construct a flyover or a underpass so that I add additional capacity on that section, and so I reduce the volume to capacity ratio. So the transportation planning is all about, in this traditional supply centric approach, is to just reduce this V by C ratio. But we have never understood that this ratio can also can not just be decreased by always increasing the capacity. That means the road infrastructure. It can also be reduced by reducing the volume, which is where we are talking about traffic management, demand management, understanding travel choices, and so on. So while this ratio has been used for so long in transportation planning, but it's still not been understood very well by our people sitting in urban local bodies. So this whole idea of flyovers, underpasses, road widening, which are traditional supply centric measures, are no longer found to be sustainable anywhere in the world, and especially in countries and cities where our population is still growing. It is not saturated. Unlike some of the countries where for 100 years the population has not increased or it is decreasing, for a long time. We are still seeing an absolute increase in the population and also migration to bigger cities. Now, this also means that there is a growing emergence of interdisciplinary approach. Whether you talk about positioning mapping and remote sensing, it has become part of our daily life. Yeah, everybody uses navigation, everybody orders a Ola or Uber, everybody orders food through Zomato or Swiggy. Everything is now based on these technologies, and there's a growing understanding and use of it for better transportation planning. There are also foundational, methods. I come from a traditional civil engineering department. My undergraduate is in civil engineering department, but I hardly do anything civil engineering today, because that's not the approach, as I said, is sustainable in terms of solving our traffic problems. So we have moved away, as far as transportation engineering concerned, from a mechanics based approach to also deriving a lot of these fundamental methods like data sciences, operations research. There are a lot of these transportation problems which can be classic optimization problems and OR problems. Modeling and simulation is being extensively used. It could be a wonderful tool to basically give decision support on several layers of transport planning decision process. Consumer theory is and economics is being substantially used, especially when you're trying to understand the travel behavior, how people make choice for different modes, different routes, and so on and so forth. Likewise, of course, there is a substantial use of communications, electronics, IT, big data and IoT, image processing in transportation problem solving. And now, what's happening to our city? And I keep showing this slide every public forum I go to drive down the point what's happening with our cities. Our cities are currently trapped in vicious circle of congestion. It started all through, from the early 1990s, when there was a sudden, you know, uh, opening of economy, economic reforms and so on, and that led to a huge increase in the uh, sorry, that led to a huge increase in um, the income level of the large middle class in the country. Okay, and that led to a huge exponential increase in car ownership since then. Yeah, that time it used to be a really a um, aspirational aspect for middle class to own and use a car. Yeah. Today it's a normal thing for every middle class family to own and use a car. But it was not so. but that aspirational aspect still remains. It probably was that time was just about owning a Maruti 800 or a Fiat. Today it's about owning a big SUV truck. In US they call it as truck, yeah, or going forward, BMW, uh, Mercedes, limousine, and so on and so forth. So the aspirational aspect doesn't stop. Now, what this did, because car ownership, of course, is the symbol of wealth. It's the way to flaunt your wealth. Um, it's high time for us to probably decouple, flaunting wealth from car ownership and think about other ways to flaunt your wealth, which are less harmful and hazardous. So what it did was, it certainly led to huge traffic congestion and delays on our road network. Yeah, a city like Bangalore, ever since the IT boom happened in the city, it suddenly exploded from a small city to a big city without railing a transition. Yeah, and so the roads in this city, which were meant for a small city, were too less to accommodate so many cars. Yeah, and so we suddenly find frustrating that, look, the large middle class, we aspire to own and use a car, and now we are not enjoying it. So then what do you do in a democracy? You put pressure on political representatives, bureaucrats, that please give us more road capacity so that we can enjoy our aspirational aspect. Yeah. And so, of course, the way democracy works is the politicians will do things that keeps their constituency. So they'll then keep on trying to increase the road capacity and road space. And this is what has been happening if you look at last 2-3 decades of interventions, and even today. Yeah, when what major projects government of Karnataka is thinking is tunnel road, double decker flyover, signal free corridor, etc., etc. Yeah, we haven't gone away from that because that's where they see the constituency for them, so called. Yeah, so you add uh, more public pressure to increase road capacity. They give you more road capacity, widen road, flyover, this and that, all that. What does what does that do? It makes the movement by car more easier and faster. Now, interestingly, there is a piece of research which has kind of determined what is the average distance people travel, uh, um, average time people spend in traveling um, per day for commute purpose. Right from automobile, start of the automobile era, it has not changed. Roughly 1 to 1.2 hours per day is what you spend in traveling on an average. But what has changed over time? You know, the kind of automobiles, the kind of faster modes that you have, and the kind of faster ways that you have. Now, what this has done is, once the movement by car becomes easier, it, it favors the urban sprawl, the horizontal spread of our cities. And you can imagine, whichever city you come from, whether it's Bangalore or some other city, how much horizontally they have grown, the kind of urban sprawl the cities have seen. It's also because we have created faster ways. So now you're traveling, now you're living at farther spaces, but still traveling in the same roughly in the same time, but with faster modes and these faster ways. But what does this do? You're then spending, you're probably taking more trips and for longer length to do the same set of activities that you were doing earlier. And in no time, we see that the congestion is back. So then you say, oh, one decker was not enough, let's have double decker. So government will say, okay, we'll have double decker. Tomorrow then they'll break that, they'll say, no, we'll have triple decker and so on. And the quest for having more and more road capacity will keep on going on. Now what we also don't see, so the congestion comes back in no time, and then we again keep asking for more road capacity. So this is how we are trapped in the vicious circle of congestion. How do we come out of it? So when we know that people are getting wealthier, make car ownership difficult. Today you every day get at least 3 to 4 calls or messages that your loan is approved, please come and collect. Yeah, if this is how easy financing is available, yeah, of course people will keep buying more cars. Yeah, there are countries, for example, that may charges more than 100% of your cost of vehicle as lifetime tax, as a way to discourage car ownership. You also need bring policies to discourage the use of car. That means the miles traveled on the cars. Okay, and again, there are congestion charging, for example, in London or Singapore is one example. If you go to European cities, most of the European cities, city center are traffic-free areas. They don't, allow traffic to enter or restrict parking spaces in those areas. These are again ways to curb the travel, the amount of travel you do on your personal cars. Of course, we have not saturated our infrastructure. So when you think about infrastructure, don't think about, again, keep widening roads and those things. Invest more on sustainable modes. Build and expand your MRT system. Infuse more bus services, more buses, more bus routes, and so on. Improve your walking and cycling infrastructure. Yeah, and prioritize their movement. Give priority for their movement. Uh, Many European countries, when you travel in their cities as a pedestrian, you feel privileged and honored like a king. Because as soon as you are at the corner of the road trying to cross, the next people will stop and say, "Sir, please go." Yeah, and sometimes, I tell them, please don't, treat me like this, because as soon as I go back to India, I'll have to, face all the gullies and all that. Yeah. Mixed land use strategies. If you can live closer to where you work or go for education, then it's easy for you to adopt a active mode or a public transport. Yeah. So better integration of land use and transport can also help us move to sustainable modes quickly. So these are some of the ways in which we can cut out of this vicious circle. And this whole idea of sustainable urban mobility has to be woven around this. Now, we also have to see and understand what's happening with our car ownership level in the global context. There is a very interesting graph. On the x-axis, you have GDP per capita in US dollar terms of different countries. On y-axis, you have car ownership per thousand population. So it basically shows how car ownership per thousand population has grown when countries were increasing on their GDP per capita. Now you have these flags of rich economies, US, Australia, Japan, Germany, and you have BRIC countries here, including India. Yeah. So what has been seen historically in all these developed or saturated economies, that as they were growing on their GDP per capita in US dollar terms, they have seen this S curve kind of relationship of the growth of car ownership per thousand population. So S curve means there's a middle steep growth curve, which was roughly seen between $5,000 to $20,000 US dollars per capita. Okay. Now, and then they tend to saturate at somewhere around 600 to 800 cars per thousand population. Uh, so US is somewhere around 800 cars per thousand population. You know how much the country average for India is? Roughly 20-25 cars per thousand population today. If you think about a city like Bangalore, we are hardly 200-250 cars per thousand population. So we are nowhere close to the saturation levels that have been observed while we are a growing economy. What is our GDP per capita currently? Hardly 3,000. So we have not even entered the steep growth period. And you already look at what situation we are and our cities are and the externalities that are. Can we imagine Bangalore or Mumbai or Delhi to reach 600, 800 cars per thousand population? What kind of city you are imagining? And how much more you can, pump road infrastructure to accommodate that many cars? So the bottom line is, the moment you add more infrastructure for roads to accommodate these cars, it will get filled in no time, because we have not reached any saturation level so far. We are still far away. So where does our future lies? We are not going to compromise on our economic growth. We are a fast growing economy. Prime Minister has said next 25 years is Amrit Kal. 2047 we want to become a developed economy. That means we want to reach at least somewhere around 18 to 20,000 US dollars per capita. Does that mean that we should compromise on our economic growth just because our car ownership will increase? No. Best is to decouple car ownership from economic growth and saturate at much lower level of car ownership levels. This is where the future for our country lies. This is how we should look at how our cities should develop in future and transport system should develop in future. And there are already examples even in these OECD countries that some have higher level, like United States has much higher level of saturation of their vehicle kilometers traveled as compared to say countries like Germany and Japan. So while they have higher car ownership, they have contained their vehicle kilometers traveled substantially. Now, so what do we get in terms of just from this? So transportation planning should no more be about just removing these congestion points and think about this V by C ratio and add more road capacity. Rather, we should focus on reducing total vehicle kilometers traveled by all motorized modes and reduce dependence on fossil fuel. Eventually, it should make our cities more livable. What should be a development goal for any intervention you do in our cities? It should be to make our city more livable, increase the quality of life. If that's not what happening, then why are we doing these kind of interventions? What for? Yeah. And standard of living is very different from quality of life. Yeah, we have to keep that in mind. So focus on person capacity, not vehicle capacity. Our transport system is not meant to transport empty cabins. Our transport system is meant to carry as many people and goods per unit time in given direction as much as possible. Yeah, so person capacity should be the focus, not vehicle capacity. There should be a strong systems approach, as I said, to develop strategies. So what we should focus on: reduce number of motorized vehicles, reduce total motorized vehicle kilometers traveled, and also fix India's energy mix to renewable sources. This is really where our strategy should focus. Everything that you do with urban mobility should focus on these three things for a sustainable mobility future. So what we need is a bundle of interventions, combination of planning, regulatory. For example, here I'm talking about increasing network coverage of public transport, cycling and walking infrastructure, but I am also talking about defining car restricted roads, congestion pricing, introducing, mixed land use, and even all buses and cars running on electricity as a, shift to renewable. And you can top up this with what we have learned in pandemic policies that would help reduce the need for travel. We have seen how we could reduce the need for travel, by working from home or flexible working hours and so on. So if we top up that and with these kind of interventions, this is where the future for sustainable mobility lies. And when I really think of today and ask this question that did our cities really learn anything from pandemic? I'll say nothing. We learned nothing. We have brought back our transportation system to even worse than it was pre-COVID. Now, I am very much aware that speaking about restricting car ownership and use in a five-star hotel in front of industry leaders could be extremely hazardous for a speaker. Bidisha might already be getting some threat calls, remove this speaker from the podium. What is he talking? Many of you must be angry with me. And you'll say, are you suggesting that we should stop using personal cars altogether? Are you saying that government should not build any roads, any more roads? You're saying that we should use public transport or walk and cycle even if the connectivity is so poor. I mean, I'm sure all of you can stand up and say, Professor Verma, what do you know? How far the metro station is. There's no bus. Footpath is very bad. This problem, that problem. I can't cross the road. And you're still saying that we should use these modes. I'll say no. That's not what I meant to say. You would also say that why only rich should use car, rather create a system and empower everyone to use a car. Is that a picture that you would like to see? In fact, in one of the public forum, uh, uh, a scientist from ISRO keep arguing this point, that why are you talking about restricting cars? Make system where everybody should use a car. So I would like to rephrase it different. I would say that why rich should only have a good standard of living. Even a average middle class person or a poor person should also have access to higher standard of living. But please decouple car ownership and use from standard of living. Okay, and I would also like to quote this famous, quote from the former mayor of Bogota, Enrique Penalosa, who said once, an advanced city is not one where even the poor use cars, but rather one where even the rich use public transport. But the point is, anyone, including me or you, will not use sustainable modes only. I mean, you will use it only when they become an attractive option for you to use. Okay, not because I'm saying this today. So the point is, urban mobility is not like a buffet meal. Okay, what we are trying to do with projects like double decker flyover is trying to offer a buffet meal for commuters. You use car, you be happy. We have provided you one deck. Somebody is using public transport. We have provided you another deck. Let everybody be happy and satisfied. Just like a buffet meal where you offer so many varieties of food that everybody is happy. You like chicken, you eat chicken. You like paneer, you eat paneer. Let everybody be happy. That's not the way urban mobility is. It is about reaching an equilibrium, or in other words, an optimum, where while everyone's travel needs are satisfied with reasonable level of service, we also have a balance of trip mode share that enables a sustainable uh, mobility and livable cities. And for Bangalore, we can expect this to reach when 80% of all our daily trips, this is all backed by research, long years of research. If you really reach 80% of all your daily trips on public transport, walking, cycling, that's where the equilibrium will come. Okay. Again, I am emphasizing the point that you're not going to use them unless they become an attractive option. What does this mean? So, if you take a public transport journey from your origin till your destination, there are several components of that. You have a first mile, which could be any of these modes. You'll have then a combination of bus and metro, changing these routes, changing from green line to purple line or whatever it be. Yeah, and then again there will be a last mile till you reach your destination. So every time you travel between 2 points, you'd always weigh your options. This is pure consumer theory. Okay, you have your mode as public transport available. What is the attractiveness of my whole journey versus using my own personal car or two-wheeler or a cab or etc. etc. Okay, and we model it or define it as a utility. So each mode offers a utility. You would choose a mode which gives maximum utility for your given travel. So unless the public transport gives you a seamless experience and the utility at least as comparable to a personal car or even higher, then only it will become an attractive mode option. So we have to work towards that. For sure, public transport journey will not become attractive if you keep building more roads, if you keep making tunnel roads. Tunnel roads, who is going to use? Hardly 8% of the trips in the city. Yeah, buses cannot use tunnel roads. Walk and cycling, people cannot use tunnel roads. So who is using tunnel roads? Only the personal cars. Yeah. So you have to focus on optimizing the complete origin destination journey. Okay, then only it becomes attractive. Now mathematically we model it as a sequence of utilities. So each mode has got a utility, which is the equation comprising of this, and this utility term is a combination of all that factors that matters for you: travel time, travel cost, comfort, cost of travel, etc. We put them together as a mathematical equation and try to convert this into monetary or a time terminology. Okay, so what we do is, you would choose a specific mode only when the utility of that mode is greater than the utility of other modes. Okay, so if you, for example, have bus, car, metro, some other modes as different options, okay, you would have this kind of utility expression, probability expression, where the probability of choosing public transport or any other given mode would be a function of the utility of the corresponding modes. Clearly, if you create, for example, construct a double-decker bridge between the given origin destination pair. If you are traveling by car, you'll zip fast very quickly, you'll not stop on the bridge and reach faster. If you're using this metro on that double-decker bridge, the metro will stop at every station for boarding and lighting. It will certainly be a much slower mode than your personal car. How will you make public transport attractive in that case? So I keep saying to these metro rail officials that by constructing these double-decker bridges, you're putting death nail to your system. You're making it further unattractive to use. Now, what are the data requirements which can benefit from smart solutions? When you think about infrastructure development, you have to have data about trip generation, OD flows, mode choice, route choice, etc. Um, for operation and management, you need data about traffic congestion, speed, travel time, reliability. For maintenance of road, you need to have regular data about road condition assessment, transport network assessment, and so on. For even policy and planning decisions, you need data about all these aspects, including destination choice of people, route choice, mode choice, and so on. Um, Even for ensuring safety and security in transport system, you need data about accident data, and prediction, crime detection, black spot detection, and so on. And even for law enforcement, intelligent violation detection, penalization, and things like that. When you think about agencies, BBMP, for example, can benefit in terms of their road and traffic infrastructure, including their development and maintenance activities. If you have smart solutions, BMTC can benefit substantially with improving their bus services, route planning, metro, of course, in terms of their train operations, city police in terms of law enforcement and safety, and also other departments on their several aspects that they do. So we are aware of some of these data sources. For example, CCTV cameras, drones, they can help us, study the patterns of vehicular movement and traffic movement and so on. Um, you have smartphone data that can help us analyze the route and destination choice. You can have, Bluetooth, IoT sensors and so on that can again help us in pattern and variations in traffic and so on and so forth. But what you need is a combination of these sensors and also combination with traditional data sources in transport planning. So this fusion actually can help us. Okay, how much more time I have? I know this shows time's up. Another 5 minutes can I take? Okay. Yeah, so in terms of big data analytics and IoT, we can make use of macro and micro simulation uh, to support the decision making, whether it is policy planning and so on. We can help forecast the future demands. We can plan and design infrastructure, give real time feedback on existing systems, better traffic signal coordination, information system, mobility as a service platform. Of course, more and more development of CAVs. Also, although CAVs is a distant future for us. Policy evaluation and formulation and so on. But we need a lot of capacity building, both in academia and practice, to achieve this. Okay, so these are some of the real issues. While we talk about technology, traffic police, they have a wonderful assemblance of technology, but there's no analytical capability they have. Okay, all that they're doing is looking at the video and taking some decision. This is not the way. When you travel around the city, you will see that the policeman is just taking decisions on halting traffic on some lanes, letting some other directions. But how much it has a network effect, how this junction action is impacting the traffic at other junctions, they don't understand. So we need really a dedicated team of traffic engineers and ITS professionals. I've put traffic management in red because that's not the function of traffic police. Traffic police should not be doing traffic management. They don't have technical capability and capacity for that. Yeah. Likewise, I'm highlighting the issues with BMTC. They also have a lot of these assemblance of GPS tagging and all those things. But what they're doing at maximum is video wall, just video fall with no capability of high-end analytics that they can perform. Again, they need, much more ability to handle these kind of data sources. BBMP, we can keep talking about. There is circular economy of potholes that is running in the city. Yesterday, you might have seen 660 crores have been announced by the deputy CM just to fill the potholes, which will reappear within few days or weeks. Yeah, so there is circular economy of that. There are a lot of issues with because of the poor workmanship in the road engineering works that these agencies are doing. Unless you fix that, these are baseline conditions. We don't have even uniform geometry. You don't have proper use of signages, markings, signals. How will you top up technology on that? Everything is going to be suboptimal in that situation. And this whole top-down decision-making process, the CM or deputy CM will decide whether flyover is good or tunnel road is good and something else is good. I know the organizers are standing on my head. So I mean, you are dealing with this kind of traffic, yeah, not this kind of traffic. China has found its own way to deal with this situation. They have, put all the two-wheelers onto the cycle lanes, low CC. They have banned all high CC two-wheelers in big cities, and so the rest of the traffic is more homogeneous. It's a more easier way. It's not easy to do, of course, that in India. Also, when you're at a junction, when your arrival rate of traffic is too heavy and your departure rate is low, your junction and network is operating at saturated conditions. So no matter how much of intelligent signaling you do, it's not going to work because your traffic is at saturated conditions. So you need to first bring down the number of cars so that the traffic is at unsaturated conditions, and then you can manage it well with smart solutions. Okay, I'll stop here because I don't think I have time for this. There's some case studies that I wanted to present about how these micro simulation models and some other things that we have done. I'll just go to the can you just go to the last slide, the second last slide before thank you slide. I just want to present that and then I close. Yeah, just keep going. You can have a look what I had all in my presentation. Yeah, just keep going. Oh, no, this is not the last slide. Go back. Okay, they don't want to show this slide at all. Next. Yeah. So the challenge is how do we decouple political economy from urban transport projects, especially these road infrastructure projects? Because these projects are done not for solving traffic problems, but to support political economy. The moment we find that answer, a lot of our problems will get solved. Also, a word of caution, urban mobility looks very simple to tackle. Every road user has got their opinion, yeah, but it's actually a complex system. So with that, I stop here. Thank you.
For more content on tech and leadership, subscribe to NASSCOM YouTube channel and press the bell icon to never miss an update.